In last video we discussed up to conditions for angle of minimum deviation till this much. Okay, then today we'll start the next topic, that is to find out the relation between angle of minimum deviation, angle of prism and refractive index of prism. So suppose we'll start with Snell's law. So now Snell's law we have that sin I by sin R is equal to mu. Suppose this is given equation number 1. Then in last video already we got the condition for minimum deviation is E is equal to I or I equals to E, this one. Okay. Then this equation we already got, delta equals to I plus E minus A. Here I have written delta M. Delta M means this angle of deviation is the angle of minimum deviation. M stands for minimum. Okay. So delta M, when the angle of deviation delta becomes delta M, in that case we can write I is equal to E. So in place of E, if you write I, then I plus I will give us twice I. Okay, so twice I minus A. Now this A will come this side, it will become plus, so delta M plus A equals to 2I, or I is equals to delta M plus A by 2. Okay, this value of I we are going to substitute in equation number A. But before that, again the second condition we are applying, the second condition for minimum deviation, that was R1 equals to R2 equals to R. If it is so, we have this equation also. In last videos you got this equation, R1 plus R2 equals to A. So if R1 and R2 both are equal, which is equal to R, then R1 plus R2 will give us 2R. Okay, so 2R equals to A and R equals to A by 2. So here we got the value of R, here we got the value of I. These two values we are going to substitute in equation number A. Okay, so equation A implies sin I means this time we will substitute this value, sin I by sin R is equal to mu. So this is the equation which relates refractive index, angle of minimum deviation and angle of prism. So I hope it is clear. Another thing, this graph, this is a graph between angle of incidence versus angle of deviation, and the graph goes like this, it is U-shaped like this. Okay, and here you can see the minimum value of angle of deviation is this one. So this value we denote it by delta M. Delta M is angle of minimum deviation. You see that the angle of deviation is decreasing, it is reaching a minimum value and then it is again increasing. So this value, this is the angle of minimum deviation. Okay, then in next videos we will discuss about dispersion of light. Okay, just little bit I will tell now. Dispersion of light means when a white light falls on a prism, we get the emergent light we get 7 colors, that is Vibgyor, right? This is the white light. White light, the example of white light we can take the light which comes from sun. So this white light, when it falls on the prism, in this side, in the emergent side, we get 7 different colors, and these 7 colors are nothing but violet, then indigo, then blue, green, yellow, orange, red. Okay, the two extreme colors are violet and red. So the definition of this one, dispersion, I have written here, phenomenon of splitting up of white light into 7 different colors is called dispersion of light. Now the reason behind dispersion, why dispersion takes place. So generally this is white light, it consists of 7 colors. All the 7 colors have different wavelengths. Red is having the maximum wavelength, violet is having the minimum wavelength. Okay, now we have this equation, we call it Cauchy's formula. Mu is inversely proportional to square of the wavelength. So more the wavelength, less is the refractive index. So that means all these 7 colors, they have different wavelength. So as a result, the refractive index for all these 7 colors, though all the 7 colors are falling on the same prism, but due to their different wavelength, they will face different refractive index. And another formula we have, delta is proportional to mu. So since all the 7 colors are having different refractive index, their angle of deviation will also be different. They will deviate by different angles, and as a result we get the splitting up of light. The light, all the 7 colors, they do not form same angle of deviation. They form 7 different angle of deviation, and as a result they got splitted up. I think it is clear. Suppose just an example. Okay, here I have drawn one diagram, this one. Here you can see violet, the extreme color, the lowest color, red, another extreme color. Okay, so you see that white light is going this way. This is the original direction of incident light. Then what happened is, due to refraction, which takes place twice, once in this surface, once in this surface, the red color, it is deviating this way. And we know that how to find out the angle of deviation. The angle of deviation, just a second. Okay, to find the angle of deviation, we take the extended incident light, we take the extended emergent light, and then the angle formed is the angle of deviation. So this is delta r, means angle of deviation formed by red light. For violet the light goes like this, and for violet, if you calculate the angle of deviation, this violet light should be extended backward, and this big angle is the angle of deviation for violet, delta v. So now you can see that delta r and delta v, they are different. Since they are different, we are getting split up. Red is above, violet is below, and in between red and violet we get the other 5 colors. So I hope it is clear. Why? What is the reason behind dispersion? So first you have to start with the Cauchy's formula. You will write Cauchy's formula, and there you will say that since lambda and mu are inversely proportional, or square mu is inversely proportional to the square of the wavelength. So wavelength of all the 7 colors are different. As a result, their mu is different, and if mu is different, by this formula delta, angle of deviation, is also different. So all the 7 colors deviate by different angle of deviation. As a result, we get the splitting up of light. The explanation is given here, you can go through. Okay, then this diagram just now that I told, this one, here the difference between delta v, means angle of deviation for violet, and the angle of deviation for red, delta r, if you subtract delta v minus delta r, then this value is called angular dispersion. This one, we are taking two extreme colors, violet and red. The angle of deviation for both these colors are respectively delta v, delta r. Delta v is greater than delta r, so if you subtract delta v minus delta r, this value gives us angular dispersion. Okay, then for thin prism, if you remember, we got this formula, delta is equal to mu minus 1 into a, right? So this formula, if we use here for violet and red color, we get this one. Delta means I have written delta v, equals to mu means I have written mu v, means it is the refractive index faced by the violet color. So mu v minus 1 into a, and delta r we can write like this, mu r minus 1 into a. Alright, now this two value, if we substitute in this equation, delta v minus delta r, if we do, so this minus this, if we do so, what we'll get? This one. So angular dispersion is delta v minus delta r, which means this minus this. If you do so, a this you just open the bracket and do the calculation, you'll get this one, mu v minus mu r into a. This is the another expression for angular dispersion. Okay, then another term is there, dispersive power. So dispersive power means it is the ratio between angular dispersion and mean deviation. So angular dispersion, already we got this one, delta V minus delta R. Mean deviation. Mean deviation means generally we take the deviation of yellow light, because wavelength wise if we see, then the wavelength of yellow is almost in between the wavelength of two extreme colors, means red and violet. It lies almost at the middle of red and violet. So that is why yellow light generally we call it mean color, and the deviation of yellow light will be mean deviation. Okay, so dispersive power means it is the ratio between angular dispersion and mean deviation. So I have written there y for yellow. Then delta V minus delta R means this value, okay. Then delta y means we can write this one, because we have the formula. What was that? The formula that we used, delta equals to what? Mu minus 1 into A. So here mu y, sorry, delta y for yellow, mu y. So it will be delta y is equal to mu y minus 1 into A, this one. So A will get cancelled and we'll get this value.